Okay, Assalamualaikum and hi everyone. So today in this video we are going to start a new chapter, which is chapter 5, vectors. So for vectors we have 4 different subtopic, 5.1 until 5.4. So for this one, for today's video we are going to learn about vectors in 3 dimension. But before that, let's see the summary for chapter 5. Okay, so you're going to learn 5.1, which is very basic vectors in 3 dimension. And then we are going to see what is a scalar product, and we are going to see vector product, and you are going to learn about application of vectors. As you can see from here, we have 6 different applications. Okay, so before that, let's start with the basics about vectors. So we are going to cover about types of vectors and addition, subtraction, and scalar multiplication of vectors. Okay, so let's say here we have the axis. Okay, as you can see from here, let's see here, vectors in 3 dimension. Of course, we have axis x, y, and z. Okay, so from here, you can see that we have, let's see this one, x, y plane. Okay, so we have x, y plane. So what does it mean by xy plane? As you can see, axis x, y. So this is x, this is y, so this is xy plane. Okay, xy plane is the same thing as z equals to 0. Okay, when z equals to 0. Let's say if we have x, z plane. Okay, we take axis x, z. So this is x, z plane. So the same thing as y equals to 0. So the same thing yz plane is when x is equals to 0. Okay, so this is very basic. And we have vector direction, direction vector. So this is the x-axis is I. Let's label that as I. This one is j, and this one is k. Okay, so we are going to learn more about this in application of vectors, about plane and line. So let's see about this one here. Let's see if we have a point P1, 2, 3. Okay, what does it mean by P1, 2, 3? So this one represents x, this one represents z, y, this one represents z. And the same thing, I, j, k. So this one here is 1, this one here is 2, and this one here is 3. Okay, and let's see this one here. So if we have a point P1, 2, 3, P1, 2, 3 here, so the direction vector is here. Okay, so we have, this is the origin. Okay, position, or we call it as a position vector. So 0 here is I, as we said before. So this gonna be 2j, and this one here is gonna be 3k. Okay, remember this is x, y, z. Okay, this is your I, j, k, because if this one we have 1, 1, 1. Okay, so let's conclude that, where we have I is actually unit vector along the x-axis, j unit vector along the y-axis. Okay, so the same thing for k, unit vector along the z-axis. Okay, so that is what IJK means. So as I said before, O is the position vector. Okay, so if you see the direction vector OP, that means from the origin, direction vector from O to P. Okay, as you can see from here, direction vector from O to P. So what is the direction vector O to P? From here we know that this one here is I plus 2j plus 3k. Okay, so let's see more on types of vectors. So that is what vector is in a axis. Okay, in a plane, or we can say in a 3 dimension lah. Okay, so let's see types of vectors. We have a position vectors, which I mentioned earlier. A vector that starts at the origin. Here, start at the origin is called a position vector. So the position vector of B is the vector that starts from the origin and ends at B. So we can say OB here. So this arrow here represent from O to be. Okay, so let's say this is the most important thing for vectors. There are 3 types to write your vector. The first one is, as I showed you earlier, we have OP is equals to, let's say we write as I plus 2J plus 3K. Okay, so this is the first way to write your vector. Mesti kena ada ombak ni dekat kamu punya IJK. As you can see from here, let's see here, from the printed notes here, dia boldkan. Okay, IJK dia boldkan. That means that is a vector. So bila kita tulis, you have to put this with here. Okay, kalau tak ada, that does not mean a vector. Okay, so your final answer will be wrong. So please remember, if you do a vector question, mesti kena ada ombak. Okay, so the second way to write your vector is by OP. Let's say the same thing. OP is equals to 1, 2, 3. Okay, this is, we call it as column matrix. Okay, column matrix form. Okay, this is one way. The same thing. I plus 2j plus 3k, the same thing. 1, 2, 3. This is also called as a vector. And the last one here, we have, let's say we have OP. We put in like this. 1, 2, 3. Okay, mesti kena ada yang ini. Dia mesti kena sharp. Tak boleh round bracket. Kalau round bracket, you have to put it as column matrix. Okay, kalau dalam row, mesti kena ada comma, mesti kena sharp macam ni. So that is 3 ways to write your vectors. Okay, either one lah. Depends on the question. So let's see. The second type of vectors, we have a zero vector, which is the zero vector denoted by 0 has magnitude 0. So let's go to here. Vectors. What is actually a vectors? Okay, so kamu semua pelajar-pelajar physics, you should know what is a vectors. Okay, vectors is something that has magnitude. Okay, which is what in magnitude? Magnitude ni apa? Magnitude is length. Okay, something that have length and also direction. Okay, so that is a vector for us. Okay, something that has a magnitude and also a direction. So here we have a zero vector, which is denoted by 0 that has magnitude 0. Okay, let's see the third one. We have a unit vectors. So this is a very important unit vector. Ramai yang akan terlupa apa itu unit vector. So a unit vector of a vector A, okay, vector A here is a vector whose magnitude is 1. Okay, that means the length is 1. So in the direction of A. Okay, so this is the formula to find your unit vector. Okay, this is the formula to find the unit vector, or we can write it as, let's write any vectors. Okay. So any vectors which has a magnitude of 1 unit. Okay, so from the formula there, we have a unit vector which is represent as this one here. A, ombak, and ada sharp here, ada hat. Okay, or we can call it as A hat. Okay, sometimes we call this as A hat. Ataupun unit vector lah, cara yang senang untuk sebut. Is equals to, so the formula is the vector over by the magnitude. Okay, so this is what we call as the magnitude, which is the length, and this one is obviously the vector. Okay, so unit vector, not a hat, let's put that as a unit vector. Unit vector is equals to the vector over by the magnitude. Okay, so if we can write in a vector form, let's say your vector is xyz over by the magnitude. How to find your magnitude? The magnitude is, the formula for magnitude is square root of x square plus y square plus z square. Okay, please remember, to find the magnitude, this is the formula. Okay, x square plus y square plus z square. So here, if we write in a vector form, that should be xi plus yj plus zk over the same thing. Okay, square root x square plus y square plus z square. Okay, so that is one thing, unit vector. But from this point, you know how to find the magnitude and also a unit vector. So make sure you remember this formula here. So the fourth one is a parallel vector. Okay, so here we have position vector, zero vector, unit vector, and here we have a parallel vector. So if the vectors u1 and u2 are parallel, then they are scalar multiple of each other. What does it mean by scalar multiple of each other? That means u1 is equal to lambda u2, okay, which is lambda can be any number. So let's see if we have a line here, a vector. Let's say this is a vector u1 and this is the vector u2. If these both vectors are parallel, that means, and they go in the same direction, that means theta equals to 0. We are going to study more on this, and your lambda has to be greater than 0. Okay, vector, same direction, lambda has to be greater than 0. And what would happen if the vector goes in opposite direction? Okay, if this is u1 and this is your u2, what will happen if the vectors go in opposite direction? Your theta will be 180 and the lambda will be negative. Okay, your lambda is less than 0. Okay, so the last one here is a perpendicular vector. So let's see here if you can write that. Okay, so okay, here we have a perpendicular vector. If vector A and B are perpendicular, hence the angle between A and B is 90 degrees. Okay, 90 degree. That's this obviously. Okay, so let's see one more thing here. One more point, which is F, a negative vector. So what is a negative vector? A negative vector means same magnitude but opposite direction. Okay, opposite direction. So let's say if you have PQ, okay, so let's draw a triangle here. We have PQ and we have the origin here. Okay, you want to find the direction vector from P to Q. So from here to here, PQ. Okay, so that means you have to go PQ. You want to find PQ, that means you have to go PO plus OQ. Okay, that is how you find the your vectors. So you want to find this direction vector PQ, so you have to go PO plus OQ. So here we should have equals to PO plus OQ. Okay, so what is a negative vector? Negative vector, same magnitude but has opposite direction. So from this one here, we can change to PO. If you want to change to OP, you have to put negative. Okay, so let's say put OQ in front here, OQ. And here we have PO. Let's say I want to put PO on in the back. So that should be negative OP. Okay, so that is meant by negative vector. So PO, we change direction, you should put negative there. Okay, so that's it. Just a very basic introduction for vectors. So let's go to addition and subtraction of vectors. So this is very basics. So this is what we call as magnitude. Okay, I explained this earlier. This is the magnitude, which is you have a vector V, you have to square root A square plus B square plus C square. So let's draw one more triangle here. Okay, so we have U. Let's say this is the direction of U. This is the direction of V. So you go in direction U, V, that means here will be U plus V. Okay, dia mesti berlawanan dia tak pergi macam ni. Okay, dia tak pergi here, here, here. Yeah, it should be here. Okay, so this is direction vector of U, this is direction vector of V. So U plus V is this here. Okay, so let's just go straight to the example, which is example 1. We have expressed the position vectors of the point A and B in terms of unit vectors I, j, and k. Hence, find the vector AB and modulus AB. What does it mean by this one here? This asks us to find the magnitude. Okay, so the question asks us to find the vector, the direction vector of AB and the magnitude of AB. So here you have, let me draw that, we have A, B, and also you have O, okay, which is your position vector. So the question asks us to find AB here, which is the question asks us to find this one here, AB. So what you have to do is we have to go from here, from AO to OB. Okay, that is what we are going to find, AO to OB, then we get the value of AB. So basically, we have AB is equals to AO plus OB. Okay, so but now, if you see from here, the position vector of the point A and B. So what is a position vector? We know that a position vector is the vector that start from the origin. Okay, that start from the origin. Maksudnya that start from 0. So from here, sorry, not 0, from O. So from here we know that OA is equals to 2I plus 3J plus 5K. Okay, so this is actually your OA and this is actually your OB. OB equals to negative 2I plus 6J plus 2K. Okay, remember this is your position vector. Position vector starts from origin. That means this is OA, this is OB. Okay, but the problem now here is we have AB. We want to find AB. Okay, the formula is AO plus OB. So what can we do here is actually we only have OA. We don't have OA from here. Okay, we have OB here. So what you have to do is you have to put negative, because this one we want to find OA. Okay, because we have OA here, so we have to put negative. Remember the negative factors, or the easiest way to do this, if you want to find your direction vector, that means AB, we are going to do from A, kita akan mula daripada belakang, which is we are going to start from B. So to find direction vector of AB, you have to do OB minus OA. Okay, just go like that. You don't have to do this. Okay, you don't have to do this. So to find the direction vector, we have O back minus O front. Okay, so here we have our OB equals to negative 2I plus 6J plus 2K, and OA minus OA is 2I plus 3J plus 5K. So this is what you are going to do, which is we are going to do subtraction. So basic thing, I minus I, J minus J, K minus K. So here negative 2 minus 2, we have negative 4I. 6 minus 3, we have plus 3J. 2 minus 5, we have minus 3K. So this is basically your direction vector of AB. Okay, so the question also asks us to find the magnitude. This magnitude here. So the formula to find the magnitude of AB is equals to square root of A square, B square, C square. So we have negative 4 square plus 3 square plus negative 3 square. So the answer here is square root 34. So we have the direction vector, we have the magnitude. Okay, so very, very basic question for vectors. Just remember, your position vectors is vectors that start from origin. Okay, starts from origin. That means O what? Okay, so let's see another example here. Find 2a minus b, modulus of 2a minus b. That means the question asks us to find magnitude. Okay, by now you should know what does it mean by the modulus here. Okay, so we have to find the magnitude. So just find this one inside here first, the vector first. So we have 2a. Always remember to put the ombak. Okay, you have to put the wave dekat bawah, below the letter tu, baru dia diconsider sebagai vector. So here we have 2a. A is I j k minus b negative I plus 3j minus 2k. So here we are going to get 2 plus 1, we have 3i. 2 minus 3, we have minus j. 2 plus 2, we have plus 4k. So to find the magnitude of 2a minus b is equals to square root 3 square plus negative 1 square plus 4 square, which is we end up with square root 26. That's it. Okay, very easy, very simple. So let's go to the next example. Example 3, given vector A. Remember, this is column matrix form. So this is the same thing as 2i plus negative 3j minus 4k. Okay, the same thing. Okay, so given vector A and vector B, find vector A plus B. Okay, so let's find that first. A plus b. Okay, how to use the column vector? The same thing, but you don't have to put your I, j, k. We have 2, negative 3, negative 4 plus negative 1, negative 1, negative 4. Okay, so here 2 plus negative 1, we have 1. Negative 3 plus negative 1, we have minus 4. And lastly, we have negative 4, we have negative 8. So that is the vector for A plus B. So next, the question asks us to find the magnitude. So again, formula to find the magnitude, which is modulus of A plus B equals to, so the formula, we have 1 square plus negative 4 square plus negative 8 square equals to, here you should get, press your calculator, 1 plus 16, here should get 81. So 81 is equals to 9. Okay, so we have the answer for the first one, vector A plus B, we have the magnitude. So next, here we have these two things. Find a vector of a magnitude 3 units in the direction of vector AB. Okay, so read back the question. The question doesn't say find the magnitude. The question asks us to find magnitude 3 unit in the direction of vector A plus B. So what does it mean by magnitude 3 units in the direction of vector A plus B? So let's see one more time the type of vectors. We have a unit vector here. Unit vector of a vector A is a vector whose magnitude is 1 unit. Okay, magnitude is 1 unit. So that is your unit vector. So something about unit vector that we have to find here. Okay, so let's find the unit vector first. So here we have the unit vector, which is, what is the formula for unit vector? Let's write this as unit vector in the direction of A plus B. So we know that the formula, unit vector is represented as U hat. Okay, U hat. So the formula for unit vector, we know that A hat is equals to vector over magnitude. Okay, so now you should have equals to vector A plus B, which we already have here, 1, negative 4, negative 8, over by the magnitude, which is 9. Okay, so let's write that in a vector form. So must write in ijk form. So we have 1i negative 4j minus 8k. So that means we have 1 over 9i minus 4 over 9j minus 8 over 9k. Okay, so that is your unit vector. But the question doesn't say find the unit vector. So you have to find the magnitude 3 units in the direction of vector A and B. You have your unit vector, which is unit vector is a magnitude 1 unit, okay? Whose magnitude is 1 unit in the direction of A plus B. So this is only 1 unit. So what we want to find here is a vector of magnitude 3 unit how to spell unit, unit, in the direction of A plus B. What we have to do here is simply multiply. We want to find 3 multiplied by the unit vector, that is 1 unit there. So 1 over 9i minus 4 over 9j minus 8 over 9k. So the final answer should get us 1 over 3i minus 4 over 3j minus 8 over 3k. So that is what the question asks. Okay, so question asks A plus B, direction vector A plus B, we have it here. And then the question asks about magnitude 3 units in the direction vector. So you know that unit vector, keyword is unit vector, is 1 unit. Okay, unit vector is 1 unit. This thing here is 1 unit in the direction of A plus B in this case here. So the question asks for 3, so you simply multiply. Okay, so that is example 3. Okay, example 4 you can do it by yourself, very easy, plus minus there. Let's just, okay, that's it for 5.1. Okay, I'll give you the answer for example 4. We have 3i plus 5j minus k, and here is I plus j plus 3k. Okay, so I'll see you guys in the next video for 5.2.